This is question number 2. The no-slip condition means that a fluid sticks to a solid surface. This is true for both fixed and moving surface. Let two layers of fluid be dragged along by the motion of an upper plate as shown in figure 1. So this is figure 1. The bottom plate is stationary. The top fluid puts a shear stress on the upper plate and the lower fluid puts a shear stress on the bottom plate. Determine the ratio of these two shear stresses. So in figure 1 here, so we have two plates. So we have a fixed plate here, so means the U is equal to 0 meter per second, and the top plate here is pulled by certain velocity as capital U here. So and then in between these two plates we have two types of liquid. One is mu1, means dynamic viscosity of 0.4, and the other one is mu2, the dynamic viscosity of 0.2 Newton second per meter square. So and then the gap, the fluid here is shown here, which is 0.02 meter each. So and then we assume that the velocity distribution for these two fluid is shown like this. So for fluid number 1 here, fluid number 2 here, so it has no slip condition at the bottom here, and then the velocity triangle, the velocity distribution will become like this. So and then start from here, there is another velocity distribution because the fluid 1 occur at this area. So bear in mind that in this location there are no slip condition, because in this location fluid 1 is interacting with fluid 2. So it is totally different with what happened on this surface, because on this surface the fluid here is stick on the solid surface. So that's why the phenomenon called no slip condition occur. So this is the solution. First, you need to understand the equation for shear stress. We have tau equal mu du dy. So and then you need to understand the meaning of du over dy. So du over dy means the difference of velocity over the difference of y-axis. So here the difference of velocity for tau number 1 here. So this is, so tau number 1 means we are focusing on fluid 1 here. So it is mu is 0.4, it's given in the question, and du here is 3 minus 2, which is, this is the maximum velocity here, which is 3, and this is the minimum velocity, which is 2 meter per second. So we deduct 3 minus 2, and the gap is 0.04 minus 0.02. So we get the value of shear stress caused by fluid number 1 here is 20 Newton per meter square. So and then we could calculate the shear stress for fluid number 2. So fluid number 2 is lay at this area. So we do the same thing. So this is the value of dynamic viscosity. So and then we calculate the difference of the velocity here and the difference of y-axis here. So we get the tau 2 is 20 Newton per meter square. So and then if we want to get the ratio, so we divide T1 over T2, and we get that the ratio is equal to 1.